So these are definitely the problems we need to draw pictures on, and this is going to be the Pythagorean theorem problems. Really helps to have the pictures on these, I'm telling you. So a 25-meter ladder is sliding down a vertical wall, so the distance between the bottom of the ladder and the wall is increasing at 3.5 meters per minute, because everyone likes to slide ladders down a wall. Not really sure the real life application, but we're going to go through it. So let's think about that again. So we have a wall. Let's draw a building real quick. There's our building. Put some door on it, some windows, decorate it, right? And there's going to be some guy on a ladder. Really tall ladder. And there he is on the ladder, or floating right off of the ladder, right? And so this ladder is 25 meters. That's a constant. Ladder height isn't going to change at all. So you can picture this ladder slides down, it's going to get kind of like further and further. That this point, the base of the ladder is going to get further from the wall, right? So it's going to slide down the wall, so that means we're going this direction. So that the distance between the bottom ladder and the wall is increasing. So then that means the bottom of the ladder is that distance between that and the wall is increasing. So let's just call this X and this Y. The vertical distance will be Y, horizontal distance will be X. So we know that dx dt is increasing at 3.5. We know x is increasing, that distance is increasing. And I guess it would make more sense if I drew the ladder over here so we can think of a coordinate plane. X is going to the right, is increasing. Too late. So at a certain instant, the top of the ladder is 7 meters from the ground. So at a certain instant, the top of the ladder, which is up here, is 7 meters from the ground. So y equals 7. So really read these carefully and label that information, because sometimes they're going to give you the change in y. Sometimes they'll give you the change in x. You just got to pay attention. What is the rate of change of the distance between the top of the ladder and the ground at that instant? So the rate of change between the top of the ladder and the ground. So here's the top of the ladder and here's the ground. You wouldn't find the rate of change between the top of the ladder and the base of the ladder because they'll never meet. So we're going to find the top of the ladder and the ground, that vertical distance. We want that change in y is what we're going to be looking for. I don't know what this was. I believe it was a 7. All right. So what do we know? We know that x squared plus y squared equals 25 squared. How do we know this? And we know this because what we have here is a right triangle. So we can use the Pythagorean theorem. So let's go ahead and take the derivative in respect to t on both sides. So we'll have 2x times dx dt plus 2y times dy dt. Then the derivative of the constant is just 0. Let's plug in what we know. We don't know x yet. We'll find it though. We know that dx dt is 3.5. We know y is 7. And we're looking for dy dt. Okay, so what is x? How are we going to find x? So this is kind of a classic problem. We saw this actually in the previous unit. So we know that from the original function, we're going to get x from this. We have x squared plus 7 squared equals 25 squared. And I'm not sure what 25 squared is. All right, and then we're going to subtract the 49. Square root that. Let's hope it works out. And it does. So 24 is going to go right here. All right. So 7 times 24, because 2 times 3.5 is 7, right? So 7 times 24 is 168. So we'll subtract that 168. And then take 168, we're going to divide it by 14 to get 12. And there we go. Let's look at another problem. This one's the same idea, the same ladder problem. Just got to be careful. This one, it's giving us the distance between the top of the ladder and the ground is decreasing. So this time they give us dy dt instead. And then at a certain instant, the top of the ladder is this many. So just, same idea. You're going to do the same stuff to figure out that. Just, draw the picture, label it. Here we go. This one's a person standing in an intersection. So you can picture an intersection. Cars are coming both directions, right? So there's a person standing at this intersection. So a person stands 30 meters east of the intersection. So if you think about this, north, south, and then we have east is over here, and this is west. So there's a person over here. And watches a car drive away from the intersection to the north at 17 miles per hour. So there's a car over here driving away. My car looks ugly. So he's driving away. So he's driving this way, right? So that means dy dt is increasing at a rate of 17. Because we're going up on the y-axis, right? And then at a certain instant, the car is 16 meters from the intersection. So y equals 16. What is the rate of change between the distance? What is the rate of change of the distance between the car and the person at that instant? Okay. So we have x squared plus y squared equals z squared. So we have our x. Oops, I don't know why I would use that. We would have our y. And then here's our z. We know that x is also 30. That's going to help. And we also know this person's standing still, so he's not moving at all. So dx dt would be 0. It doesn't say he's walking or traveling, so he's standing still, so his rate is 0. So let's find this derivative. So we'll get 2x times dx dt plus 2y times dy dt equals 2z times dz dt. And what we're looking for is we're looking for the change. We're looking for dz dt, right? So let's plug in all the information. So we'll have 2 times 30 times 0, because he's not moving at all, plus 2 times 16 times 17 equals 2 times z times what we're trying to find, dz dt. What is z? Well, we know this. We're going to find z from here. We have x is 30 y is 16. So let's just put that in the calculator. It's 34. Times 2. So let's go ahead and calculate some of this. So we have 2 times 16 times 17. It's 544. And then 2 times 34, 68. So we'll divide the 68 to the other side. To get 8. So that distance between the car and the person, the change in z here, is going to be 8. And that's how you solve these problems. I'd say that might be the most difficult one, but these aren't too bad. If you build the situation, use the formula, it's really not that bad. I mean, seems like quite a bit of work. It's really just kind of messy. That's why you got to be organized. List everything you know. What do you need to find? Create a formula, derive it, plug stuff in, and you're good.